All right, in the previous video, we covered some basic stuff, like some beginner terms about statistics and population, census, parameters, and whatnot. We're taking a bit of a step further now. So we have our census where if you have a population, right? Population is what you're interested in, right? You have the option of performing a census if possible. That's when you can ask everyone. Now, you prefer that for smaller groups, but sometimes if it's a larger group, you can get a census done. It just takes a lot of work and a lot of resources. So sometimes it's just, too costly. It's just beyond what we can do. In that case, if you can't ask everybody, then you do a sample. You ask a small group of your population. So instead of asking like maybe 900 people, you ask maybe 30 people. And then from that, you come up with some sort of summary, which would be a statistic, and then you can generalize it to your population. Now, in each of these cases, right, whether it's a census or a sample, we collect data. In the course of that, what you do is maybe, again, we'll come back to, let's say, average, we'll say screen time, right? Screen time of high school students. Now, if you want to do all the high school students in the state of Massachusetts, census is going to be really difficult. You probably want to do a sample there. If you want to do it for a very small high school, maybe, then you could probably get away with doing a census, where maybe if it's a high school of only like 100 people, and you can manage to do it, awesome. But then you ask people, all right, whether it's a sample or a census, you say, okay, how much time do you spend on your screen? You go to, that setting in your iPad or your phone, tells you your average screen time. They tell you, that's the data, that's the information you're collecting from these people. Now, there are different types of data within statistics, and that's what we're going to talk about today. Types of data you have. We're going to start out with one. And this is referred to by several terms here. Sometimes you'll see it called qualitative data, or the one I prefer, especially because it's easier to pronounce, is categorical. This is the type of data that you can't really record as a number, right? This is something that has to do with a quality, right? So we'll say a category or a quality. It can't be represented by a quantity, really. So what do they mean by that? Like a qualitative or categorical category, right? This would be like eye color. If you ask someone what their eye color is, they're not going to say 6. That's not, you wouldn't be getting a number or something you can measure from that. They're going to give you like blue, red, and things. You can't really put that stuff in order. Well, obviously they're not going to have red eyes, excuse me, but blue or brown, right? And that's not something you can really numerically order either. So that's something that'll be qualitative or categorical. Eye color, hair color. Right? These are things that are qualitative or categorical. Gender, that's another one. Let's see, maybe country of origin. If you ask someone a question and they can't give you like a quantity or something measurable, that's when it's going to be qualitative or categorical, if you can just put them into a category. Like, or type of music, that's another really good one. If you ask someone, what type of music do you like? They're not going to say 3. No. They might say, I like country, I like rap, I like rock, I like classical. Those are all different types. These are all qualitative or categorical, right? And how can we represent this stuff? Chances are you've seen it represented before. Bar graphs. Bar graphs are great. There are a lot of different bar graphs you could have. So what could a bar graph look like, right? Like maybe if we're doing eye color, you could have like blue, brown, and then we'll even just put here other. And then you'd represent it, these individual bars, right? And then over here you would have, on your y-axis, your frequency, how often it comes up. Frequency means just how often something happens, like how many people have blue eyes. Like say 1, 2, 3, 4, 5. So this is 5, right? All right. And then up here it might be 6 and then 7. Okay. So we get 5, 6, 7. That's what's represented here in your bar graph. Your x-axis, you have to represent it using categories. That would be a bar graph. And you notice that your bars don't touch. I hate to stick by that. The reason is because you can have bar graphs where you get lines touching. And I'll show you. Maybe you want to separate this by gender, right? And I'm trying to find my eraser. Oh, it's right here. Maybe you want to get creative. Sometimes people do this, right? I'll show you. You have a bar graph, it looks like this, right? And maybe the other bar looks something like that. Maybe this one, and then that one, right? And then here, and then maybe it looks like that. This would be a case where you have bars that do touch each other. You just break them into categories. Like maybe this represents males, and these represent females. That would be a case where you do have bars touching. So that's why I always try to stray from the whole like bars touching, not bars touching. What you want to remember is that you have qualitative or categorical data right here on the x-axis. That's how you can tell you're dealing with a bar graph. You might also see a two-way table. And I guarantee you've seen some of these in the past. Like a two-way table would be when you'd have categories split up a bit, right? You might have here, like, let's say, males, females, and then here we'll have like blue, brown, and maybe over here you'd have your totals. This would be a two-way table, and you can see we have the different categories represented. We have males and females here, and then we have eye color here. So the total of your blue, you have 6 males with blue eyes, 8 females with blue eyes, you get 14. 7 males with brown eyes, 2 females with brown eyes, you get 9. And you get total 23 down here. And likewise, 13 males, 10 females, 23. That would be an example of a two-way table. And that's another way you can represent this quantitative data that we're talking about. That data that's represented by categories. And again, you like bar graphs, two-way tables. Those are awesome. Now, the thing is with these, you don't necessarily you can't really summarize it by saying like a median eye color. You could say a mode eye color, definitely like the one that happened the most here was blue. That would be your mode, right? The piece of data that happens the most. You wouldn't necessarily be able to give a range. I guess your range would be blue to brown. By me, you don't have anything like lesser value to a greater value. You can't really represent an average eye color. You can't average it out in between blue and brown. So, I mean, those are some of the limits you have with qualitative data. You can mention a mode, but you can't necessarily go with a mean, a median, or a range. So those are some of your limits here. So that's one set of data you could get, qualitative or categorical, right? Other type of data you can get is something called quantitative data. And that's data that you can measure or, use, let's see, quantitative. I'm not going to win a spelling bee spelling that out, I'll tell you. It seems like every other time I spell that, it's wrong. But what quantitative data is it's data. It's represented by values, right? By actual numbers. And the numbers mean something too. The numbers are ordinal, right? Because like 0 means something as opposed to 4. They're not just random. They mean something, right? I'll say mean something in relation. So let's see, like quantitative data. That would be like if we're talking about screen time, right? Because you get an answer in minutes. So let's see, some examples would be like, number of minutes. Height, that would be quantitative data. Age, Again, numbers. You're thinking about numbers here. Wait. Here's an example of data that has numbers, but that is not quantitative. Like a zip code. A zip code is represented by numbers, right? But you can't say that, like, 01511 is any different than 0512, right? There's no real ordinal values here. It doesn't mean like this is less than this when you're talking about zip codes, right? Because they don't necessarily represent quantities or measures. They're just numbers assigned to describe something. So that would be an example of numbers that could be used that aren't necessarily quantitative. So that's important to know. Yeah, quantitative is, when you can represent by numbers that mean something, something that measures something, right? They measure something, and they mean something in relation to each other. Now, within quantitative data, right, you get two different types. And this is where people get a little confused sometimes, so bear with me, I'm going to help you out here. With quantitative, right, you can get discrete or continuous. Discrete only have fixed values. So they can't be decimals, can't be fractions. They're very fixed values. I'll put typically can't be decimals or fractions. I'll give you a case here though where you could see some fractions, like discrete, right? An example of this is one of my favorite examples. Shoe size. If you ask someone their shoe size, right? There's only a fixed number of values you can get from them. They might tell you, I take a size 9. I take 9.5. I take 10. You'll notice that with shoe sizes, you're not going to find anything between 9, 9.5, and 10. These are fixed values. That's an example of discrete data because when someone gives you an answer, there's only a certain number of possibilities you can get. You're not going to get like 9 3/7. You're not going to get 9 15/16. That's not possible. This is all you're going to see here. Another one would be like number of cars. Like you're trying to figure out the number of cars in a parking lot, right? You're not going to count half of a car. A car is a car, right? So you're only going to get, like 10 cars, 12 cars, 52 cars. You're not going to get 52.3 cars. That's not possible. That's discrete. Number of people, that's another one. I've had students argue with me about this one. You only can have a whole person, regardless of what you think about your sibling. You can't say that your sibling's half a person or 3/4 of a person. That is a person. So, number of people, these are all discrete, right? Now with continuous, you can take on any decimal or fraction. An example of continuous, right? You'd be looking at something like height. You might be thinking, now wait a second. You only can measure like within inches, right? Well, think of it this way, right? You might ask someone, how tall are you? They'll say, I am 60 inches tall. Someone else might say, I am 61 7/8 inches tall. Someone else might say, I am 66 and we'll say 3/16 inches tall. As you can see, there are a lot of possibilities here. It's not just limited to, rounded inches here. Height is an example of something that's continuous. You can get all sorts of different values between that. Another one is GPA. People get really focused on this. Someone might have a 3.4 GPA. Next person might say, well, I have a 3.47. Oh yeah? Well, I have a 3.72. In that case, you're thinking, okay, now you're getting down to some different values here. GPA is an example where it can take on any sort of fraction or decimal. That's continuous. So you have discrete and continuous quantitative data. Again, that's when you measure it by, counting, like something you can count or measure. A lot of times they tend to refer to discrete as counting data, continuous as measuring. But again, I like to think of it this way. Discrete is your fixed values. It's only fixed, can only be these. Continuous can literally take on anything. And how can you represent this data, right? We start talking about bar graphs for qualitative data. Well, unfortunately, you can't use bar graphs for this data here. If you have, let's see, discrete data, right? A good way you can represent this is called a dot plot. How does a dot plot work? Well, say we have like number of cars, right? Here's how you can represent it. You might see 1, 1, 2, 2, 2, you have 3. It's a nice visual representation. You can see that down here on your x-axis here, you've got all the possible numbers, and then up here represents your frequency. Now again, frequency is the number of times something happens. How many times you see a particular data point. That's frequency. So a dot plot is a great way of doing that. Now another way you can do that. Go with your dot plot. You can go with a histogram as well, and that can apply in both cases here. Because histograms are great for continuous data, because a histogram, right? Oops. Shows ranges of data in your x-axis. It represents ranges, right? So if you're talking about height, you could create a histogram based on that, where you go with 60 to everything just below 65. So 60 to maybe like 64 and 15/16 could go here. Anything just below 65. And then everything from 65 to just below 70. Not including 70, just below. And then from 70 all the way to just below 75. So your ranges here represented on your x-axis, and up here would represent your frequency, right? So maybe we have, yeah, I did this very rough. 1, 2, 3, 4, and then like 5, 6, and so on. Your frequency would be here in the y-axis. How often you see that? Like maybe you get 4 people between 60 and 65 inches tall. One of the downsides of a histogram, though, is it doesn't give you exact data sometimes. You wouldn't be able to tell someone how many people are 61 inches tall based on this histogram. You wouldn't be able to tell someone how many people are 64 inches tall. Here's the reason, right? We only know that we have 4 people that are between 60 and 65 inches. All those people could be 63 inches for all we know. We don't have that information here within the histogram to tell us. So that's a downside of a histogram, but it can be great for condensing data. You're going to find that very useful down the road, so bear that in mind. So with histograms here, you get ranges of data. Whereas with a dot plot, right, it's very specific. It's very fixed, right? Excellent. So you got histograms, you got dot plots, and this helps you at least get an idea of what types of data you can get. So just to review, right? You collect data. You can get data that is quantitative, which is represented by numbers. And again, those numbers are like ordinal. They represent something. They're all something in relation to each other. Or you can get qualitative. Think about it this way, right? Quantities goes with quantitative data. And then qualitative or categorical, these are qualities, categories. How can we represent this stuff? If you got quantitative, it all depends. If it's discrete, we like dot plots. If it's continuous, we like histograms. Remember, histograms show ranges, dot plots show very fixed values. For qualitative or categorical, you can represent it using bar graphs. Two-way tables are good too. Probably seen pie charts before too, or circle graphs. You're not going to use them too much in this course, but that is a way that you can represent this stuff. And this is just to kind of get you started, of course. You're going to learn a bit more about all these, how to put them together. But this is just some basic stuff to kind of get you started with these basic terms. Hopefully this helps you.